All right, sounds good. Good morning, everyone, and welcome to another excellent employer session. We're super excited to have you join us today with some folks from SRP. So I'll go ahead and kick it over to Josh Schwartz to get us started and introduce his team.
Good morning, everybody. My name is Josh Schwartz with SRP Talent Management. I'm in the talent acquisition group within human resources, and I head up a program called Talent Pipelines and Partnerships. And this morning we do have a presentation for you on some of the more technology-related positions within SRP. And so I have Angela Scheibel with me from cybersecurity, Kyle Cormier from Telecommunication Systems, and Mike Feaster with Transmission Generation Operations. Each one of them have a presentation for you with a little bit of Q&A at the end of their presentation, but feel free to pop in and ask questions as you have them. So I'm gonna go ahead and screen share and pull up the presentation for you. Right, is everybody able to see that?
Yep, I can.
All right, perfect. Just want to make sure the technology is working here. Okay, so again, we have Angela, Kyle, and Mike, and they're going to go through their presentations, and Angela is going to kick it off with what cybersecurity looks like at SRP.
Good morning, I'm Angela. Can you guys hear me okay?
Yes,
Yep.
you're good.
If we could go to the next slide. I'm Angela Scheibel. I work for SRP. I've been at SRP for over 20 years and just about as long as in cybersecurity. I've had multiple roles in the cybersecurity aspect, from identity access management, granting access, to an architecture roles in various business areas, including our power system, which is the software and hardware and tools used to get power to your homes. And then I've done a compliance role. NERC-CIP is a regulation. It's a federal entity it's a critical infrastructure protection. Essentially, it's cybersecurity, but it's regulated and we're audited on it, which is a good time always. And then enterprise cybersecurity architect, and then to my current role as a manager in cybersecurity. I mentioned my communication style here. I'm a little bit direct, so if you need me to elaborate anything, please don't hesitate to pause me, and I would be happy to. And my contact information is just below. Next slide, please. So what we do from an enterprise cybersecurity perspective at SRP is protect and empower people, processes, and technology to be a positive force in creating, managing, and maintaining a secure digital environment for SRP. There's administrative and technical controls, and when I use the term administrative here, I'm more talking in a process capacity than actually administrating a technical tool. And those controls can range from preventative to correcting action, detecting something, responding to those detective events, eradicating and removing those events or remediating it. And then we're constantly measuring effectiveness so we continually improve and sustain, pace with the threat landscape. And how we do that, next slide, please, is we have an enterprise cybersecurity program that consists of, several key management areas. Risk management, where we're evaluating the risk to SRP and what we need to do to reduce that. We have an awareness, communication, and education program. So much to an education perspective, it's our responsibility to help our users understand the risk of what they're doing. Simple phishing emails, right? Our users are at the endpoints, and we have like 5,000 of them at SRP. So that's 5,000 people that can help us protect our system. So that's critical in my perspective and doesn't get a lot of play. We do data protection. And you'll now start to see privacy in there, and you've seen this probably recently with personal identifiable information and requiring laws and protections. California is the most current and recent, and having a full thought-out process on requiring what's needed for that. Vulnerability management, making sure our systems are patched and have current updates. We manage our resources from a people and technology or tools perspective. The people piece is making sure they have the right training, the right environment to do their job so that they're effective. And then the technology is making sure that that augments what the people are doing, but also that fiduciary responsibility and that we don't have redundant technology and stuff we're not using and paying for. We do architecture evaluations, new or changes in our environment. We look at a holistic picture of that and make sure that we're not creating weaknesses in our environment. Managing access there and identity access management. And then we have a threat management function, which is probably more commonly known to as a security operations center, where they're hunting and looking for malicious events. And then also if an event of interest turns into an incident, how do we respond through that through cybersecurity incident response? And then also that continuous improvement. We're constantly measuring, gauging metrics, doing gap analysis so that we can improve these areas through controls. And if we could progress to the next slide. I'm not going to spend a lot of time on the next 4 slides, but how we do that is in those areas, what we have are controls, and there's a top 20 controls that we use. And when I got this question, it was regarding tools. And what I'd like to do with these slides is hopefully change your perspective of that technology doesn't solve the problem. It's great to have these tools, but they're really augmenting the people and processes you establish for the business. Depending on your business and your risk and what you're trying to mitigate, depends on what tools you'll need. But generally, these foundational controls for cybersecurity are applied across environments. There's 5 at the top at a basic level, and if you could progress, then you'll have a few at a foundational level that are required. So based on how big your business is, what your risk toleration is, depends on which of these controls you implement, but they've kind of set down this roadmap for these being the top 5 you should do, foundationally consider, and then if you progress again, you'll see some more foundational. That you want to consider for depending on your business, and again, the risk. And then lastly, they have, and if we could progress again, is organizational controls. And this again gets kind of back to that administrative piece where we're talking about educating the employees, your incident responses. If we do have an event, what are we doing and how we practice that so that we can manage a data loss event, or if a system's had malicious software installed on it. The last one I'll mention too that we can do internal, or you can contract out actually, and there's roles for that, but is the penetration testing. So this is where we validate our controls and have someone actually test it. So my point with these 4 slides, although brief, and I believe these will send out, Josh said, or they mentioned that these will be sent out at the end of the presentation, but is to have the focus on the controls. And then I did provide the list of tools underneath. Some of these are free, some of them cost, but depending on the business need, it just varies between what businesses use. May I have the next slide, please? In regards to career paths at SRP, in particular, at SRP, this is generally kind of the ladder for it. You can start at an intern, then you move to an associate, a junior level, a senior level, and then you can move into a principal or a lead. Our principal roles are more on the technical side, where our leads are transitioning to more of a leadership. And then you have your leader and executive leader positions as well. And I'll talk a little bit later about what the core requirements are there. Yes, please progress. Thank you. We could go forward. Yeah. And so preparation and application for the roles in cyber, and maybe quite frankly anywhere, but is really key of application. And so those critical controls that I gave in the tools, some of those tools are free and people can start using those at home. Again, caution, your family may get annoyed if you do take down the network trying to use one of them, but it is a good way to practice because at a smaller scale, you have a lot of this at home that you can start to understand. Mentoring opportunities, volunteer opportunities, again, the free tools, community resources, and then I'd like to add on the community resources. There's a lot of threat intel out there, like Krebs security online, those things. Start getting that threat intel so you're processing it and then understanding, okay, that's control, we could do this, we could do that, and it's that problem solving and strategically designing solutions that mitigate these attacks. There's a lot of administration that's key. Your firewall, network tools administration, even endpoints, meaning your desktop. There's controls around those too that need to be understood. And if you can administer those systems, then you'll start to understand how those controls can be applied. Scripting is really key because a lot of the tools don't always do exactly what we want them to do. And so scripting helps us build bridges between the tools or allows us to augment our processes. And then risk calculation and evaluation. As I said, many tools can be used across different businesses, but really, and in addition, the controls, understanding what the risk is and the impact to the business is huge, and it will determine what the business does, because cost versus the implementation of a control may be outweighed, and you may not do that and choose to do something different. And that's very lost in cybersecurity. We get you'll get a threat intel and it's react. And so that mitigates that by saying, that's not a big risk to our business. This is what we should do instead, or if you need to do anything. The last thing I mentioned is power skills. They're generally referred to as soft skills, which I don't necessarily care for that term because these are huge. You can buy technical skills, but power skills are complex, and you got to continue to build those throughout your career. And so just getting early application of that, through the mentoring of the other various methods is really critical, particularly because cybersecurity in our realm is enterprise, and we have to work with businesses and understand their processes, and so that's a key skill. Next slide, please. So here is just kind of overview of education. At a foundational level education, we require a bachelor's degree in cybersecurity. We prefer it in cybersecurity or information technology is acceptable. The foundational certifications, there's the security essentials, and there's other variations, but I prefer the SANs, to be honest. They're the best training and certifications we've seen. But it's just kind of that foundational breadth of it. The number one certification I would ever recommend to anybody who wants to do cybersecurity is the GIAC Critical Control Certification. It's also offered through SANs, but it takes you through those 20 controls you saw previously, not only explaining them, what risk it mitigates, but also gives you access to some tools that you can actually go apply, audit, and see what's going on and what that control can prevent, detect, and what you can monitor. Often the DOE is a common resource for certifications on different levels, so that's there as well. I will also mention that we're seeing a transition too, where typical bachelor's degrees and more so in the master's arena, that these certifications actually can be as an equivalency versus the actual degree. So that's good in some aspects, but I still appreciate a bachelor's degree. And then as far as the intermediate and advanced, this is where you start to see more focused certifications. So depending on the role, security operation analyst versus, awareness training and education, those will start to focus. And SANS, that roadmap there, which I'll show you on the next slide, kind of provides a good roadmap of how to get to whichever area you're interested in and take the deeper dive and be more focused. I did put a couple others here that are not mentioned in the SANS because I think they're becoming prevalent, but the risk, if you're interested in being a risk analyst, there's a certification through ISACA that you can get. Data privacy and protection is becoming, I think that's the next probably biggest thing, but there's some certifications there. And then industrial controls obviously is near and dear to our heart, being a critical infrastructure. Next slide, please. The next slide just shows kind of that roadmap that SANS has. And when you actually go to this link, you can click the plus signs and it will drop down, as you can see in that first example there, and tell you the courses and then where you progress next and to the right, basically. But it'll tell you the classes and certifications for that track, if you will. Next slide, please. So as far as internal training, we have a couple different things, but we started a cybersecurity intern rotational program because the biggest gap we saw was folks graduating with their college degree, but not actually having any application. And so we do require 1 year of college credit or college courses. Basically, they need to be through their freshman year. 6 to 12, and they do 6 to 12 rotations through our operational technology and information technology that supports our critical infrastructure, so they get the actual application. They also go through a reliability and compliance rotation, which is that NERC-CIP or critical infrastructure regulation, because it's important, whatever role they have here, they need to know that we have to meet those standards. And then we have traditional programs with our employee development and talent HR group that are offered. because a lot of business acumen is also needed to work at SRP. And those are important and critical as well. And then we do offer, mentoring programs as you progress into more of a leadership. Looking for that, we do have a enterprise mentoring program as well. Next slide, please. So I struggle with the 5, 10, 15 year and what can we expect coming up? And honestly, it's changing so fast, and literally in 18 months, what we thought we knew today, we don't know anymore. And so just kind of changing this, I think that we just have to develop an agile workforce that can traverse these changes. So with technology innovation, the amounts of data we're collecting and information, and as the technology changes and the more technology we get, that workforce needs to just be agile and be able to deal and shift quickly to those. And then, also that changes our threat landscape, which again needs an agile workforce that can deal with the new threats coming out. Next slide, please. So what I see trending is we're going to get more of the cloud, where traditionally before we had a lot of on-prem. That was the standard, is that you bring everything in-house and do it from in-house. We're going to more shift to a software as a service, infrastructure as a service, et cetera, which they call the cloud. We have, not my favorite, more laws and regulations. So NERC-CIP, we're going to start to see privacy laws to protect personal identifiable information, which is good, but then we're audited, which none of us really enjoy too much. Artificial intelligence, behavioral intelligence, anomaly detection is huge, because we have so many tools giving us data, but how do you process that from a manual level with an individual? This increases our efficiency, it can help us make better decisions, or maybe make worse decisions depending on the intelligence, I suppose. But I think that's going to play a huge role. And then all this new technology and information, as I said, introduces a new threat landscape. So new channels for attacks. We didn't have ransomware before. What is that? Well, we're going to lock your computer till you give me money. So those things are going to keep progressing and keep changing with the pace of new technology innovations, and so we have to be able to adapt. Next slide, please. And that is all I have, so I will open it up for questions if there are any.
Okay, if there's no questions for Angela in regard to cybersecurity at SRP, we'll move on to our next presenter, Kyle Cormier from Telecommunications Systems at SRP. Kyle, I'll get to your slide there and you're ready to go.
All right. Well, my name is Kyle Cormier. I'm the Director of Telecommunications Systems. Been in SRP for about 15 years. Most of my time has been in the telecommunications group, but I've also spent time in our control engineering group working with supervisory control and data acquisition stuff. Also started off as an intern and went through our rotational engineering program as well. So I got to get involved with some other groups too. Next slide, please. So about the group, we're responsible for SRP's mission critical telecommunication assets, networks, and services. So we have a significant amount of fiber optic assets. We build out those wide area networks to create those pipes to interconnect our substations and our facilities. We also have field area networks, currently wireless, serving our last mile communication to where we don't have fiber optics. We have quite a few mountaintop communication sites with microwave paths, a land mobile radio system, and paging systems, and the land mobile radio systems for voice communications. We also have a commercial services group where we lease excess capacity on our fiber system, and we also do co-locations for cell sites on our transmission system. We deal with all of our leased wireline services, so anything through Cox or CenturyLink, which we don't have a whole lot of because we have a very robust private system, but anything that would be leased would also come through us. Angela mentioned the regulation there with the NERC stuff, so I won't touch too much more on that. We do have cybersecurity, so Angela's group handles the enterprise level, and we're really focused on the telecom specific level for cybersecurity. Just also wanted to note, Angela did touch on OT, IT. We're really an OT-based group, and we're found within the power system organization of the company and not necessarily that corporate IT portion of the company. So a lot of our core customers are power system groups that are operating the power system. Next slide, please. So getting a little bit more into the technologies that the group supports, we have multiple wireless technologies. with some licensed frequencies at 900 megahertz for our voice system, paging system, which we are looking to phase out in the next couple of years. I'm guessing nobody here has pagers anymore, but we do still use them a little bit. Licensed 700 megahertz system there for our field area network. So that's that wireless network I talked about that's getting beyond our substations where we don't have fiber optics and we're relying on that wireless system to provide the communication. And then multiple frequencies that are licensed for our microwave paths. Once again, if we don't have fiber, we need a wireless solution. It's inexpensive. It can be built out relatively quickly to get to those hard to reach places. On the fiber side, you've probably seen all the transmission lines around the valley. Some of you may know, or maybe you don't know, that there's a fiber optics in that grounding wire at the very top of those transmission towers. And at the bottom there's a picture of that. And that's pretty much almost throughout our entire system. As we just started deploying that fiber back in the 1990s. So we've got a very robust fiber network. And that's really that foundation that lets us start building out the networks in the next column there. Historically, we've leveraged older base technology with synchronous optical networks with GE Jungle Mux, and we're currently life cycling all that equipment out to multi-protocol label switching equipment with Nokia. We've also got some cian dense wavelength division multiplexing technology where we're lighting the fiber with multiple wavelengths to really get some increased efficiency out of this fiber. Also have the typical stuff with Cisco switches, routers. I wanted to note on timing, I think it's one that doesn't get talked about very often, but it's very important for networks. Typical stuff there, GPS. Atomic also doesn't get talked about a whole lot, but I think that's an alternate solution to GPS. And on the cybersecurity front, a lot of talk in the last year or two on spoofing or causing issues for GPS. I also have some channel banks, which is an older technology. And also wanted to note just power systems for our stuff is a little bit unique compared to traditional IT stuff. And that we power our equipment from 48 volt DC systems, and we're out, most of the IT type stuff you're gonna see off of AC systems with uninterruptible power supplies. Of course, now that we got networks, we need to secure those networks like we talked about, so we got a lot of technology there as well with firewalls, intrusion detection systems, remote access with virtual private networks, and I lumped in servers and virtualization where we have a very small role because traditionally that's more on the IT side, but we do manage some of our own servers and virtualization. Next slide, please. So real quick, as far as what career paths I'm going to focus on, there's 4 areas in telecom. One is an engineering area, one's our construction and maintenance area, another's our infrastructure, which really deals with our fiber, and then our operations area, which deals with our network management systems and really monitoring the networks we have. And within those different areas, there's really 3 career paths that are made up of most of our positions, and that's our engineers, our analysts, and our technicians. So that'll be what I'll talk about next. Next slide, thank you. So on the engineering career path, you can look at the bottom there, we've got the career ladder. We've got a very robust career ladder, which is great, a lot of opportunity for growth. But focusing in on the entry level at the associate level, the education would be a bachelor's degree in engineering from an ABET accredited curriculum or state professional engineering registration. On the telecom side, we would prefer electrical engineers, but certainly open to others that really had an interest and desire to move into telecommunications. All of our positions have a set of competencies, and most of those are going to be 5 competencies. So for engineering, it's writing and reporting, learning and researching, applying expertise in technology, analyzing and delivering results and meeting customer expectations. We certainly don't expect people to come in and mastering all those competencies at the entry level, but those will be the areas that we'll be looking for development and helping people to get to. Want to focus on customer expectations as well. We're a very customer-driven organization, not only for our external customers, but also as an internal services group, telecom is very focused on customer service for not only SRP, but of course, and then the external customers and where we do touch those folks. Training-wise, we do make sure all of our folks go through some level of vendor training for any of the technologies that they're going to be touching, whether that's with Cisco, cian, Nokia, cybersecurity stuff as well. But certifications are preferred and not required. We do have quite a bit of internal training that we'll go through as well. The vendor stuff is really great to teach you those technical skills and what the solution that they offer can do. But the SRP stuff is very focused, as Angela mentioned, on what SRP standards and processes are to implement that technology within our company. Some of those skills there, networking fundamentals are really important, of course. Angela touched on the scripting, totally agree there. Don't need to be an expert writing software applications or anything from telecom side, but certainly some scripting, macro type stuff would be great skills to have. Radio frequency concepts, we have all those wireless systems, so knowing some basics on propagation, signal to noise ratios, those sorts of things are really helpful. Troubleshooting is a big one for me in root cause analysis. A lot of stuff is moving to software-based systems, and being able to replicate a problem and identify the root cause is really difficult to do in some cases. So having some level of skills there and problem solving, figuring that out would be fantastic. Project management skills as well. A lot of our folks are given jobs or projects and really expected to manage those projects themselves. We do have some project managers though for the larger projects, but just the fundamentals on project management are important. Power system and operational technology. So, coming from the engineering side, we would hope that that person would have some background knowledge of the power system, because that's a lot of those key customers that we're supporting. And we get into some very unique requirements for those customers when you think about teleprotection of our system. So that's high level of the skills. And you're going to see on the next slide, if we can go there, Josh, it's going to be very similar for the analyst. So there is a career ladder for the analyst. Angela touched really well on that. Education, she touched on that too. Bachelor's degree from an accredited institution that prepares the employee for the assignment. We're not really looking for anything, overly specific here, but certainly something in the areas of cybersecurity, computer sciences, the technologies would be preferred. The competencies line up very well with the engineering, with a couple of changes there. The first two, deciding and initiating, adhering to principles and values, and then we get into, of course, applying expertise and technology, doing the analytics, and delivering results to meet customer expectations. Same setup for the training. We're going to offer the vendor training. Certifications aren't required, but preferred. And then, of course, yes, we do have internal SRP training. Skills are very similar to engineers as well, with the networking fundamentals and programming scripting, the troubleshooting, project management. Another one that's a little different here is just the network management systems. So that tied into that operational area where we've got all these software tools to provision and monitor and operate these networks. A lot of our analysts are responsible for those systems. Next slide, please. And then the final career path I wanted to touch on, a little different than the first two, is our technician career path. So this is really more of that hands-on person that's going to go out into the field. They're going to install the equipment, provision it based on whatever the analyst or engineer set up, and do a checkout to make sure it's operational. Trainee requirements, pretty limited there. High school diploma or GED with 6 approved college credit hours. So certainly if somebody would prefer to do the hands-on stuff and not as interested in getting a bachelor's degree, this could be a great path for them. Competencies are a little different than the first two there with the engineers and analysts. Planning and organizing, following instructions and procedures, applying expertise and technology, analyzing, delivering results. So those three again are the same. Training is a little bit more formalized here because we don't have that training from the education side with bachelor's degree. So yes, there is much more formalized program for our technicians with on-the-job training. But once again, certifications are preferred but not required. And yeah, we would make sure any of our technicians get vendor training as appropriate. Skills a little different too, as you can imagine, power tools, test sets, and leveraging those test sets and troubleshooting. Networking fundamentals, DC systems, wireless systems. A little bit unique here as well as the physical infrastructure. So, you're going to be installing racks. You're going to need to understand cables, the cable types, connection types. So different connections for fiber optic cable, different types of cable for Ethernet cable, that kind of stuff, along with grounding all these components to make sure everything's safe. So a nice third path there with more limited education requirements. Any questions on the career paths before I talk about the future?
I have a question on the career path.
Yeah.
If they come in, I'm noticing a theme throughout this whole experience that the bigger companies, if they come in, let's say as a technician, does SRP offer opportunities for education, maybe for them to go get a bachelor's and then move up that way?
Absolutely, I'll let Josh cover that one, but definitely.
Yeah, we do have a tuition assistance program that we offer. So regular full-time employees do get tuition reimbursement. We also have internship programs that get some stipend annually for their education and continued education. So we do offer that. We have internal education as well as like Kyle was talking about. So we make sure that our employees have that assistance as needed.
All right, great question. Any others? All right, so looking at the futures, very challenging, of course, getting out the crystal ball here. Absolutely going to see more convergence of the OT and IT, not only from the technology perspective, but the organizational perspective as well. For SRP's perspective, time division multiplexing, that older technology I mentioned with the sonnet stuff, is going to be gone, hopefully in the next 5 years. And we're going to be looking at a fully IP future going forward. Cybersecurity's influence is going to continue to expand with the Internet of Things, and really everybody's going to have some basic skill set in the area of cybersecurity, whether it's for work or for your personal use at home. We're continuing to transition to software-driven systems, so whether it be software-defined networking, software-defined radio, software-defined WAN, all sorts of different things being thrown out there related to software and virtualization. You know, historically, at least on the operations side of things, we've had very appliance-specific solutions and more hardware-driven solutions, and that is certainly transitioning. That really ties back into the whole troubleshooting, root cause analysis of being able to replicate issues that are going on and quickly identifying, you know, where is that issue? Because these things get very complicated with software, whether it's from the vendor perspective or maybe in a virtual environment where you have multiple organizations that are all living in that virtual environment. Well, if something goes wrong, you know, whose fault is that? Is it the person handling the underlying infrastructure or software for the virtual environment, or is it somebody on a specific application side? So definitely a big transition happening right now in that area. Angela touched on artificial intelligence, definitely growing there. Back to solving the big data problem for not only cybersecurity, but from operating these telecommunication systems where something fails in the system and it generates multiple alarms. Well, it's difficult for somebody to sit there and look at that. You might have dozens or hundreds of alarms to drill it down and find out, oh, it was one card failure in a specific asset, but it generated all of those alarms. So having something there that could do that and provide more actionable information to humans, of course, would be fantastic, so we can hone in and get things addressed much sooner. And kind of an interesting one here is wireless connectivity propagating. So from an education perspective, definitely lots of opportunities from a carrier perspective with 5G, lots of infrastructure rolling out now. Another interesting one is, to me at least, the SpaceX Starlink. Traditionally, satellite solutions are high latency, and for a lot of those operational requirements, we need low latency. And supposedly Starlink is going to provide some of those lower latency link solutions. But with the quantity of infrastructure they're deploying, certainly there's probably some future opportunities there. And that's it. Any other questions? All right.
All right, if there's no other questions for Kyle, we'll move on to transmission generation operations with Mike.
Hello, can you guys hear me okay? Can you guys hear me all right?
I can hear you, Mike.
Yep, we got you.
Oh, okay, thank you. Sorry, I didn't do a sound check since I dialed into this one. So I'm Mike Feaster. I'm manager of grid operations within transmission generation operations, our overall department. Can you go to the next slide, please? And so our area has a couple of big primary functions: balancing area operations and transmission operations. So the balancing area operations is basically dispatching the generation resources we have in our fleet, forecasting load, balancing those two things. There's a lot of things that go into that, but that's just the basic thing. And then transmission operations. So we have transmission operators that operate 69,000 volts up to 500,000 volt transmission systems and sub-transmission systems. A little bit about my background. I started with Salt River as a power plant operator and worked in that capacity for about 10 years at the various plants within the valley. I've been in system operations here in transmission generation operations for about 20 years now. Came in as a system operator, worked as a trainer, training supervisor, and then as a manager of grid operations. So our groups make use of the systems that Kyle and Angela described in a big way. So we're in operating the system, we're using connectivity, communication systems, devices in the field, and applications here that interface with all that. So we're in a way, we're a consumer of what of Kyle's efforts for sure, and then protecting us, all those systems being what Angela described. I think we can go to the next slide, please. So our transmission operators, they're monitoring the transmission system and operating devices in the field, breakers and disconnects, and they're interfacing with different field crews and resolving maintenance that comes up, whether it's scheduled or unplanned maintenance activities. And then the balancing area operations, as I said, we have those positions in our group: transmission operators, balancing area operators. And more recently, we have the energy imbalance market operations part of our job. We've added a position for that function. So there's a new set of systems and applications we use, and a new set of rules that we are abiding by to participate in that market. We've been participating since April 1st. We've been ramping up to that participation the previous 2 years. We've been working towards implementing all the things that we needed to get into that market. The other aspect of what we do here is we serve the function of a transmission service provider. We have an open access transmission tariff, a lot of rules and provisions for that are part of that, and our people basically perform that function under those rules. And then we have a group that does outage coordination for the generation and transmission assets we have. There's a lot of coordination that's involved in order to ensure that we can take those outages and operate our system and continue to operate our system reliably. We do have a training department in our group, and they develop and maintain our training programs. We'll touch on a little bit more of that here in the remaining slides. There's another group within our group called Transmission Services. They have folks that are they support the implementation of new facilities where you add a generator to the system, or you add a transmission line or an element to the system. We have different operating agreements that are associated with that. We have a lot of different systems that interface with those things that they help us. That group helps us with that the implementation of those facilities. And then also we have, I think probably Kyle and Angela mentioned, NERC, or North American Electric Reliability Council. They have requirements that they impose on us, and a lot of those requirements are we are under a great number of those requirements, so we have to abide by those. The Transmission Services groups helps us with the compliance process, which is, it involves auditing and internal compliance processes that help ensure that we are compliant with the standards, and that we have all the documentation that we need to show that we comply with the standards. And then that group also has other operation supports functions, different tools and systems and applications we use. There are engineers and analysts that help support that. Next slide. So career path-wise, we have the system operators, which form about half of our group, is made up of the system operators. And they come from both the transmission operator and the balancing area operator, excuse me, are taken from several different areas throughout the company. They can come from a control room operator position. They can come from a power plant electrician or substation electrician, or any other journeyman position where there's, those folks have typically gone through an apprenticeship and a lot of other training for fundamentals that are important to the work we do here. So they come in with that kind of a background, and then they can also come in if they have a degree as well. I think 99.9% of who we bring in are come from power plant operations and the journeyman's positions, although a growing number of those people are coming in with degrees as well. The transmission scheduler comes in with similar backgrounds as the balancing area and transmission operations. So none of them require a degree for entry, but a degree can get you in the door for those positions as well. And then we have a lot of engineering support, so roughly a quarter of our group is made up of engineers. So we have a group that is, we call operational engineering. They do a lot of system studies and modeling so they study different system configurations and contingencies, and they use a lot of specialized applications and tools to do that. And they basically help us plan in such a way that we are always operating in a safe, reliable position, capable of withstanding, one or more various contingencies that can occur in our system. The other engineering, maybe about a third of those engineers are system support. So where we have specialized tools and applications in-house and in vendor provided as well, but those engineers help support the implementation of those specialized applications. And the requirements for the engineering and the analysts are very much in line with what Kyle and Angela described. It's very, very, very similar throughout the Salt River project. And then the trainer position is usually comes from a system operator background, but we have had a few that held that position that came from other areas, engineering background, for example, and all of them. That being said, all of them do receive training on training, delivery, and development, and so on. And then we have outage coordination folks that come from the same background, typically, as the balancing operator and transmission operator. Next slide. So the education for our jobs, we have, as we talked or mentioned earlier, the NERC certification. There's a certification that is required for system operators. So NERC requires that the operators initially are tested, so they have to take the NERC exam and pass that. And then after that, they maintain their certification by receiving continuing education hours. And I believe it's 180 over a 3-year period to maintain their certification. Over and above that, we have our in-house training program. It's targeting the basic skills and knowledge and fundamentals for the job, plus all the other specialized training on the applications we use to do the work for operations. There are other vendor programs that we utilize for fundamentals, and possibly vendor programs associated with their own applications. And then we have on-the-job training where we are required to be qualified on reliability-related tasks per NERC. So there's a process we follow for that as well. And then the engineering, very much in line with what Kyle and Angela described, to be established as an engineer. When they come into TGO, they rarely know what they need to know to do their job. So there's a lot of in-house training. They receive many of the basic courses that an operator receives, and then over and above that, they're trained in the the various specialized applications they use to do their work, the different tools involved, computer tools, and other processes and procedures that are utilized to do their jobs. They're trained in-house for that, for the most part. And very much the same training type, training required for the analyst positions, very much the same as the engineering. The trainer, like I said, they typically come from the operator positions, but they do receive training on training program development and delivery. We have a lot more rigorous NERC requirements on what the training program should look like for our system operators. So they do receive a lot of training on that aspect of training, the systematic approach to training, and so on. Transmission schedulers, very much trained like the operators as well. They also have a different set of applications that they're immersed in, a little bit different than the operators, but it's very much the same type of OJT process for them. Next slide. And as I mentioned, we do have our training programs in-house, primarily focused on the system operator positions, as I said. There are I keep repeating this, but all these, we do use quite a variety of unique or specialized tools, systems, applications. So there's training on that. Sometimes that's vendor provided. Sometimes that's, we get a train-the-trainer type training from a vendor, and then we deliver it ourselves and that sort of thing. But we do train all of our folks within TGO towards those things listed there. Next slide. Just a quick education and skills list here for students. People that come here benefit greatly by having background in math and algebra, physics. Communication is big here. There are a lot of nuanced, detailed things that the engineers find themselves in, and it's very important that they have skills in communicating to others, explaining complex things to simple people is the way I would say it. Me being one of the simple ones. But in any case, and then for the operators, they find themselves in situations, high-stress situations, where precise communication is important, communicating under stress is important. That's the kind of thing that we're looking for in people we bring into our group. Critical thinking is another aspect of it, as far as there are different contingencies and scenarios that an operator will experience, and being able to critically think through what they need to act upon based on the information they have can be a very complex thing, putting a lot of pieces together. So that's very important. Analytical tying into that as well. And also with the engineering side, there's no shortage of new things and nuanced things that we have to implement and deal with and roll into our operation, that we rely on that analytical skills of our engineering staff as well. Next slide. So, future. Again, computer skills are very important. We have seen as younger people come into our group, they come in with better computer skills, more so than our old school operators, many of them. So they are more adept at a new person, younger person, is typically more adept at picking up the different nuances of our applications. They're more willing to dig in and rummage around and find the things they need to find, and they come in with those skills typically these days. Research and planning, very important for what we do in implementing new resources, new types of resources, batteries and solar and wind and other things to come. And then we have a lot of system modeling that's part of what we do as far as studying our systems, studying based on forecast conditions, forecast loads, forecast resources, building out our system and our operation to handle those things. Problem-solving skills is naturally part of all that I just described. There's rarely a recurring, repeating problem that is always the same. There's always something nuanced about solving those problems, and people that are able to pick up on details and put the pieces together thrive here. Adaptability being probably one of the biggest things. Changing, system changes over the years, that is the one constant is change for us. So we've constantly had to adapt to new rules, new systems, new resources, new types of customer behavior, and all those things. So people that are capable or have that adaptability will thrive here. I think that's very much it. If there's any questions, I'll take those.
All right, do we have any questions for any of the presenters?
Josh, will you be able to send those slides to us so we can share those with the educators afterwards? Awesome.
Absolutely, yep. I'll send them directly to you, Casey. Thank you.
Okay, sounds good.
All right, if there's no questions, that's it for us. Thank you very much for your time. Angela, Kyle, Mike, thank you so much for your presentations. Really very much appreciated.
Yeah, thanks. And if anybody has any feedback, please send it over. So always looking to grow and develop on our side as well. Thank you.
Excellent. All right, well, thank you so much, Kyle, Josh, Angela, and Mike. We really appreciate your time today. And teachers, I don't know if you have other sessions, but best of luck, and we look forward to connecting with you again tomorrow.
All right.
All right.
Thank you.
Have a great day, everyone. Talk to you soon. Bye.
Nice to meet everybody.
Yes. Bye-bye.